Okay, 1.7c in college algebra, and we are ready for example number 4. Bottom of page 153. It says graph each of the following. But before doing so, describe how each graph can be obtained from one of the basic graphs shown on the preceding pages. All right, so we will go through this because sometimes their question that they want you to solve is not hard. It's just complicated to figure out what they want. So we have g of x equals x squared minus 6. All right, so what we have here is basically an f of x equals x squared. Okay, so what are we doing to the x squared? We're subtracting 6. So if you remember, as far as vertical translations, whenever you subtract a number from your f of x, which is this, we could write this as okay, and your x squared is your f of x. So what that means, because this is negative, it's going to shift down 6 units. So if we were to graph this, and we were to graph just the x squared, it would look like this. But the x squared minus 6 is 1, 2, 3, 4, 5, 6. Just means every single point on this graph right here is translated down 6. Every single one. So see how the difference between the two graphs, and that's what they want. They want the original graph, and then they want to show what it would look like if it's translated down 6 units. Okay? Let's get rid of this one and go to B. All right, B says g of x equals the absolute value of x minus 4. Now, an absolute value on a graph looks like that. Okay, so we know it's going to look something like that. All right, but we're not sure exactly how. So first thing we're going to do is we're going to write and say, okay, the, what word did I use before? Building block of this is absolute value of x. Okay, that's kind of what we got here is an absolute value. Since g of x equals this whole thing, it basically is g of x equals the function of x minus 4, because that is what goes in the absolute value sign. So this graph right here is going to be the graph f of x equals the absolute value of x. Because of this minus, the absolute value of x is going to be shifted to the right 4 units. So if I were to write my original absolute value, it's going to look something like that. But because of this minus 4, everything has been moved over 4 units, okay, to the right because of the minus sign. If that was a plus, it would move over this way, okay. So that's the B part of this. And if this is a little confusing, don't get too freaked out about it. It's not one of those things that we're going to be doing for the rest of our lives. So it's just becoming familiar with some new stuff here. Some of you might have seen it before. Some of you might have not, and so it might be a little bit tougher for you. But okay, the key thing here is looking and seeing what the building block picture is going to be. So I do like to do this. F of x equals the square root of x. Okay, we're dealing with the square root. We're looking and seeing what is the x, what's being done to it. Well, we've got so this is the building block because there's a radical on that x. Okay, g of x though equals an x plus 2. So that means that we're not adding 2 over here, we're adding 2 to the x right there. So that means we're going to go left or right. And because it's a plus sign, it's going to go to the left 2 units. So if I have my building block radical, and it goes like that, This says I'm going to move it to the left 2. I'm going to start there and do that. So it's going to look the exact same as the first one. It's just going to go over 2. I guess I kind of made it go a little bit high, didn't it? Kind of sets it off a little bit. It goes like that. Okay. All right, so that jumps us to D. And again, I apologize for this taking so long. I'm trying to talk fast, but sometimes talking fast gets my tongue tied. All right, now notice what we're doing is we're taking that, but we're also taking 3 away from it. So what we have here is we have a horizontal translation with this plus 2. This plus 2 means it's going to go to the left 2. But this also means we have a vertical translation. So we're doing 2. We're going to go left 2, and we're going to go down 3. So when we graph the square root of x, we're going to go left 2 and then down 3. So if we were to just square root, then I'm skipping that whole thing where I write, f of x equals square root of x, the building block piece there. So what I'm doing is I'm going to go, okay, so here's my original. This says I'm going to go over 2. And this says I'm going to go down 3. So I'm right here. And it's going to look like that. Okay, so this is actually the graph of this whole thing there by the time I get done. Over 2, down 3. Over 2, down 3. Okay? All right. So that takes us down to reflections on the bottom of page 154. Okay, so reflections. Rather than go into all of the theory behind the reflections, let's just jump into the first example, example 5, and we're going to follow the rules on reflections, top of page 156. And if I can read that, yeah. And we'll just kind of go through and see how this works. So example 5 says graph each of the following. Before doing so, describe how each graph can be obtained from the graph f of x equals x cubed minus 4x squared. So what they're doing is they're saying, all right, this is the building block. This is the official original graph. And what we're going to do is we're going to tweak this graph a little bit, do some things to it, and see how it shifts. So A gives me a negative x cubed minus 4 times negative x, the quantity squared. Okay, so they rewrote it. So it's got basically the same thing. It's got an x cubed in it. It has a 4x squared. So here's our 4, here's our x squared. There's just a bunch of negatives stuck on there. So things change a little bit. So one of the things that we want to do, first of all, is we want to write, because it says in that little gray box at the top of page 156, the graph of y, let me get my pen to work, y equals f of x, negative f of x, is the reflection of the graph y equals f of x. Okay, so they're reflections, okay, across the x-axis. So if these are opposites and everything in here is the same, then they reflect across the x-axis. If y equals the function of negative x, okay, that's going to be a reflection of y equals f of x. That means it reflects across the y-axis. If the point xy is on the graph y equals f of x, then x negative y is on the graph y equals negative f of x, and negative x y is on the graph y equals f of negative x. And if you're like, what in the heck are you even talking about? Well, let's get rid of all this stuff then. And let's just do some practice here. And see what in the world we're trying to do. Basically, we're trying to graph, okay? And we're trying to figure out what is going on with the graph. So, there's my building block right here, and they gave it to you in the instructions. And then they give you this here, and they want you to graph that. But they want to describe how we went from here to here. You know, what is changing here. Okay, so let's look at reflections here. Okay, so what do we have? F of negative x. Okay, so if we can make this, if we can find f of negative x and it equals this, then I know, according to my little gray box, top one's 56, then it reflects across the y-axis, because f of negative x, if it equals my g of x, then it's going to reflect across the y-axis. So let's go ahead and do that. So let's make this work and see what we come up with. So f of negative x, we're looking at this one right here, is going to be negative x cubed minus 4 times negative x squared. So that's negative x cubed x minus 4x squared. So notice this and this are equal. So g of x equals f of negative x. Okay? Because that is the case, then it is a reflection across the y-axis. Okay? F to the negative x equals whatever this is right here. All right, let's look at B. Okay, B says h of x equals 4x squared minus x cubed, right? Okay, so let's look. So let's find out what negative f to the x equals. So what we're going to do is we're going to take our x cubed minus 4x squared, and I'm going to put a negative out here because that's what that says. So I'm going to distribute that. And I'm going to get that, which ends up being 4x squared minus x cubed, if we were to write it that way. And what does that equal? It equals that there, right? So when we did that, that tells you it reflects across the x-axis. Okay, so what you may end up doing when you're doing this is, you know, you're going along here and you have no idea, does it reflect across the x or the y-axis? So this one tells you that it reflects across the x-axis, but maybe you also want to find out if it reflects across the y-axis. Well, that's when you do the f of negative x. Okay, and so you make this negative and make this negative to find out if it reflects. So, you know, sometimes you'll have to use both of those, or in fact all three of them sometimes, to find out, or yeah, I guess there's just two of them, the x-axis and the y-axis. Sometimes you'll have to try both of them to find out which one, but the book just kind of said, all right, it reflects across this one, so let's just use that one to show you how it works. All right, let's go to vertical and horizontal stretchings in the next video.